Good morning to all. My name is Berkan Fidan. I am Performance and Process Director of OYAK Cement Group. Today, I will talk about our the industrial digitalization project and mainly the part of that decarbonization part. Try to explain that part to you. I just want to give a short intro about our company. We are just a global company. It's in Amsterdam based, CIMPOR Global Holdings. And it's a group companies established by OYAK in Turkey and Taiwan Cement Corporation from Taiwan, and operates in the field of cement, concrete, kraft paper, and bag production. CIMPOR Global Holdings operates in mainly headquartered in Netherlands, operations based on Turkey and Portugal, and Romania, Ivory Coast, and Cape Verde. We have also operational units on those countries. And we have brands in Turkey, it's OYAK Cement, in Portugal and Cape Verde, it's CIMPOR Portugal and Cape Verde. And we have operations in West Africa. The first company is CIMPOR Côte d'Ivoire. The second, also established a few months ago, CIMPOR Cameroon. We have also operations on West Africa. To just the main units, I want to say it's OYAK Cement is the market leader in Turkey with the market share of 15% in total production and largest brand in cement and concrete in Turkey. CIMPOR Portugal and Cape Verde is the market leader with 55% of market share in Portugal, and it's the known brand in West Europe. And the newest one is in Africa, West Africa. It's CIMPOR Côte d'Ivoire. It's a unique plant. We are saying that it's a game-changing plant in cement and concrete industry because it's the world's first greenfield calcined clay integrated plant. Calcined clay is a new additive product, artificial additive, replacing with clinker. The issue is that it's very low CO2 emission when compared to clinker. We will produce low CO2 footprint products with that technology. Our aim to spread it to especially Europe and all over the world. That was the first plant. When I come to our digitalization journey, it will start nearly 5 years ago. Just the aim was, the main aim, the first to collect the data and to visualize it. But the challenge was its online visualization of the plants that units operational units in 3 continents at the same time. That was the first challenge. And the other thing is we want to just try to do predictions and improve our efficiency, productivity, and quality on cement. And due to that part, in-process predictions, it was one of the challenge. And high reliability and predictive prescriptive maintenance, and also the emissions, the sustainability part, it was our aim at the beginning to collect that data and improve our abilities on that issues. What we did by the help of Pi, we designed our unique architecture to just be developed for each plant for cement industry and apply to all the plants by the help of Pi AF with standardized formats. The main advantage was it was inside in the company. There are so tiny, low amount of believers about that issue at the beginning, but it takes 110 days to apply all Turkey operations to Pi AF structure and to collect all that data. Then we try to generate and drill down original visualization structure. I will show some examples in upcoming slides by the help of Pi Vision. And now with all that, plants can use it, those Pi Vision screens, to just follow the operations. And classified text and calculated artificial data is filtering them and sending them to analysis. It was a problem for us, but we solved it by the help of Pi Integrator for business analytics. And then also we just step into the AI and machine learning stage by the help of that Pi Integrator. It helps us so much. And AI-supported predictions is also one thing. Just we could do predictions since last 2 years with the collected data. We are using automated ML structure. We are using 2 different platforms to send that data, get back the predicted data, and feed it into the Pi again. Another advantage of the feature of that, the future, you can follow the future with timestamp data. We could also follow on the Pi Vision, the actual one, the future data. We could show and people just analyze it by the help of Pi Vision. What are the benefits? It's just we are on the beginning, but especially with the help of that AI adoptions and improved quality of data and amount, we can increase our capacities and less energy consumptions, and we could increase our overall equipment efficiencies. And high accuracy and efficiency on pyro processing and grinding stage. It's critical for us because in cement industry, it's a low-tech industry when compared to the others, I know in here, but the issue is that we are collecting all of our data in our plants, and our variable costs, 90% is heat and electrical energy. All the others is only 10%. And that 90%, it's huge amount of data available with that one. Any efficiency improvement affects directly our costs because that's also critical for us. We focused on that point and we still insist on we could gain much more than by the digitalization part. And anomaly detections to predicting failures and to not just the date, but the problems, the anomalies on our equipments. It can cause our reliability failures. And also NOx emissions and CO2 emissions. Today I will focus on that part much more. As I said, the main motivation is our 18 cement plants in all over the world, more than 100 ready-mix operations, and more than 10 aggregate plants in 3 different concretes, 3 different continents. We are focusing on now for adapting that process to ready-mix operation and aggregate plants. We have started some projects to follow that trucks and to just not only that truck driving issues, we are just started to monitoring like the pressure of the tires, because it's all tiny data help us so much, like in ready-mix part. In aggregate plants, we are following 2 pilot plants. We started one in Cape Verde. Now, since last 6 months, in an island, we have 2 aggregate plants. We are getting that data and following them in Turkey and giving some instructions to that plants to help them by the help of Pi. Just an example for that business units. In total, we just checked, it's more than 800 billion individual records per year we are recording. It's a huge data for us. I know in many industries there are many available high numbers of data, but that's also very high for us. And we could use that data. We started to use that data. And quality is one other thing. It's important for us because cement is a unique manufacturing part on that part, because our today produced product quality can be approved 28 days later. We need to wait 28 days. If you could predict 28 days later, we could manage today. That help us so much, and we could achieve good results. We could predict our products' future strengths, main quality parameter. And also the continuous process relational efficiency effects and energy intensive operations, I said, low maintenance cost and maintenance parts. I just, those are so broad topics, but today the most important one, potentials on CO2 and sustainability. What are the challenges? We have huge amount of well-organized and globally connected monitoring structure. It's not so easy. We did it with Pi. We just standardized the hierarchical information for all plants and implement and replicate it. It speeded up so much. After just design the whole plant structure, we just put it to plant and connect all the signals with different sources, different brand names, different types, versions of PLCs, softwares, or other connecting units. We could do it easily. And that connections and our data sources are variety. Time stamping is critical because we try to make some predictions and AI adaptation. Time stamping is one of the most important parts. We could do it very well with Pi and also with quality side especially. The sampling is a problem. We solved it with just some QR code and just some NFC type readers and connected to the Pi system. Previously, the sample is taken from the field, in manual sample taken to lab, and you don't know in which hour, which date exactly. You could not find it. We just connected that one. Now the people just use that handheld tools while they are taking the sample with it, and we time-stamped the quality part. The quality predictions accuracy mainly based on that issue. It was critical. And dynamic editing options. We are not losing our data. That was the biggest problem at the beginning. SCADA systems just store some amount of data, but it overwrites in after 4 months, 6 months periods. Now we have in today it's more than in some plants it's more than 3 years data is available for all the signals from that plant, and nearly 80-85% is second basis. It's so frequent, but we stored all the data to do that analysis. And AI compatibility with Pi, that's also biggest advantage to make some analytics, online analytics and instant analysis. Just to show some about Pi hierarchical structure, just the screens, we designed the internal part, added with the analysis option, we added additional calculations, and not only the raw tags, we also created many artificial tags by the help of that calculations and those issues, because there are many KPIs and specific calculations required to control it. We did it, and we implement and replicate to all the plants. That was the advantage for us. Just to show you about some main screens from that, it's just our main structure. We just developed and drilled down, as I said, from global main key parameters to plants in each unit's detailed parameter. We could see actually from just anywhere in the world, and with their also mobile phones by the help of that mobile capability of that Pi. Now each plant people can use it. At the meantime, they can design also their own screens for unit-based or so any equipment, whatever the aim, process quality or maintenance part. Plant people also using that details in their plants. Now I just want to say that why CO2 and cement industry, as you see that, as all we know that after industrial, the speed up that all the issues, and not only the industry, also the world annual CO2 emissions drastically increasing. And as we all know that, it's just the popular issue of those days to just prevent it, to decrease it, to mitigate the CO2 emissions. And the role of cement industry is a little bit critical. The product is very cheap, but when we look on the CO2 emissions per ton of cement produced, just around 670 kgs CO2 emission just discharged to atmosphere. And when we look on how much cement produced in a year, 4.4 billion tons of production in 2021. It's a huge amount. And when you multiply it with that one, cement has become just only, there are hundreds of different industries, but 7% of total discharge emissions is responsibility comes from cement. And anything can be done just affect directly to CO2 emissions. Due to that reason, it's our responsibility. On the other side, also with the taxing issues, especially in Europe and now upcoming in everywhere, it's a cost for us. In these days, cement price is around 80-90 euros per ton. And today's CO2 emission price, it's just reached more than 80 euro. It's equal to our product. It becomes like that. If you want to produce per ton of cement, we need to pay a similar amount for the tax of CO2. Then it becomes also critical on the cost side also. What we are doing? What's the role of Pi in our decarbonization strategies? The first thing is online monitoring and analyzing capability. Just the details, I will show you some examples. I'm passing that part quickly. The other one is predicting emissions, guiding process control, higher combustion efficiency and less fossil fuel usage, high efficiency on grinding process and predicted fineness to decrease our electricity consumption, especially because indirect part. Reducing our CO2 footprints with the improved quality. As I said, we are focusing on low CO2 footprinted products like calcined clay, also using alternative fuels rather than fossil fuels to like SRF biomass from fuels from municipal solid waste. We just decreasing our fossil fuel usage, incinerating waste and use their heat rather than using fossil fuels and decreasing our CO2 emissions. And high productivity and efficiency on renewable energy systems. It also helps us because we are focusing also renewable energy systems like waste heat recovery with turbines to are using the heat, our waste heats to generate electricity, and we have solar plants. We need to follow them. We are planning to now establish new wind turbines, and due to that reason, we just also trying and the backside follow-up issue. While tracking emissions, just some screens, as you see that it's in all Turkey operations and plants, and the main parameters, the main emission parameters you could see in there, we could follow it instantly, like NOx, CO2, dust and SO2 and the other parameters in the pi. All people can see that. On the calculation part, especially CO2, all the industry people know that it's just need to be approved. In each year, we are collecting our data to an just authorized authority. We are giving all that data. They approve it. It takes some time. It's detailed calculations. Many parameters just need to be calculated in it. It takes long period, then approved, and each year we are presenting a data. Many companies as a yearly data is available. We just decreased first that one to monthly. Today, we could follow it instantly. And how much CO2 per ton of clinker, we could show it by the help of Pi. Every people can open it and follow it instantly. It's how much CO2 they are emitting in all over the world on unit basis. By the help of that analysis tool, we added many specific calculations in it. And we could follow that CO2 tracks by the detailed calculations in that, by the help of that PI-AF's analysis part. And predicting emissions part is critical to process control. It's like a SCADA screen, but because we added always additional things into it. But the advantage, it includes also predictions and upcoming issues in it. A plant's rotary kiln, it's one main unit. We could show it to people, just follow it to check the trends, long-term evaluation, and they can take also reports. In each day, we are sending automatic reports for plant managers and also department managers, and also just a summarized report to us by the help of Pi data link. They could check it with that sheets, and also we are feeding our BI tool to make it report on that part. Sorry. And not only the numbers, also we have started to use visuals to just make it them also as a parameter, and to use that all to that process data and emissions data, and add some screenshots from our visual cameras on the process camera. You could see it a plant's just a camera in the kiln hood. It was a usual inspection camera, but we are getting screenshots in each 10 seconds. We just linked it with, we saw that it's a huge correlation between NOx emissions and our quality. We added that data as in our analysis, in AI automated analysis, and we just generating predictions, send it back to Pi, and we could follow it, what's happening. As you see, it's a NOx issue. Just in the right side, you can say that the first one, it's one of our plants in NOx emissions. It's again a critical greenhouse gas, need to be controlled. It's important. The blue one is the actual condition, and the orange one is the prediction. As you could see that it's the continuing orange means the future data, because we predicts the future, and the plant can follow it in next 5 minutes, 10 minutes, how it's going that. There are two critical issues. It's a hazardous gas, NOx for atmosphere, and the other part, we need to decrease it by using some special, not special, the ammonia, to just injecting that one to reduce that. It's a huge cost, and again, it's an hazardous material to decrease its effect. By the help of that predictions, we could decrease the ammonia content, stabilize the NOx emissions, both cost and again, environmental impact on it. Environmental engineers can follow it and just focus on that point. One another thing, it's as I said in the process part, we could predict our free lime. In the orange one is the original. It's trends, it's just connected to points. Normally you could see 3 points in orange dots, it's small. Those are the real data, because people just go, take a sample, come back to lab, do the analysis. It takes 1.5 hours. And they send to the operational CCR, and the operator manage the process to keep that free lime. Burnt clinker, which is the main raw material of cement, try to control the process. Now we could predict in each minute to just that one, the blue one. By the help of using all that data with the Pi, we send the system, take it back, and to show it in here. As you could see that it's just fairly enough to just catch it, and what we are missing, we could see that it's in the blue part. You could see that it's high deviations happening, but we were blind at that sections because we wait the next sample. We couldn't see that deviation. Now we are feeding that detail to the APC, Advanced Process Control System. We have started 3 months ago in our plant in Ankara, in Turkey, just with AVEVA APC. Now we are also feeding that blue data. We will feed it, and to control the performance of the kiln, both energy efficiency and quality efficiency, we will use that. We connect that part to our advanced process control part. Again, you could see free line prediction. The purple one is the predicted value. The other one is the oranges. That the actual one, trend. And less fossil fuels, as I said, for like one of our plants, as I said, thermal substitution rate, replacing fossil fuels with waste is critical for us. When we started that project, that substitution rate, replacing secondary fuels with fossil fuels, was 4-5% 5 years ago. Today we achieved in Turkey operations 30%. In Portugal we achieved 45%. We could replace household wastes, old end-of-life tires, some biomass sources. It's a challenging issue because it's not like coal. You need to manage it well to process. You keep our quality. You need to burn that material. But the help of that visualization and adapting on it, it's one of our plants. It's now in one of the records in Turkey. As you see that, we replaced it 81.20 at that point in one of our plants near the Istanbul Aslan plant. That means total burned materials, 81%. That plant burns wastes, household waste. Only 19% they're burning fossil fuel. The effect is just following correctly because it's not so easy. We are inputting calorific value, some process data, and everything into it, and try to manage it. And we now just connect it to the APC system to control the process well, and we drop down our fossil fuel usage by the help of that knowledge. And automatic notifications. If something happened in the process, with all that process trends, we are sending directly email notification to process engineers and department chiefs to know that it's your calorific value is increased. You need to check it in any time in the day. It's not so usual, but it creates a stress on the people just to check it normally, because we were realized that at the end of the month, reporting the previous month, we saw that, it's just so increased. Why happened? We checked it. Now we could do it interactively because we are sending them. If it comes night, just in the morning, you checked it or increased, then try to answer it because it's an email to send to everyone. Try to give an answer. Need to push them to just solve it, because it means both, not only the cost, also now the CO2 and additional effects. That's also help us in notification part. And predicting the other figures in here, as I said. One another thing, the particle size in the grinding part is also critical. While you produce that product, you need to get a quality. We are consuming huge amount of electricity, nearly 100 kilowatts per ton of cement. In ordinary cement plant, or just say that in Turkey we are producing 10 million of tons of cement in a year. You can multiply it 100 kilowatts. It's huge amount of energy. Each consumption could decrease its effects, indirect effect on CO2 and the cost. And we are predicting again fineness. We are grinding that material to make it dusty. We are doing analysis again in each hour. But if you could predict in each minute again, like the other one, we could decrease our efficiency, energy consumption. That's like that. In the right hand side, you could see that the orange trend is again that particle samples. The red and blue one is two different models and the predicted values. We could predict in our fineness levels and use our process. In here again, the middle yellow-orange one and the upper one is the predicted ones. It's a daily data. You could see 10, 12 points, yellow points. These are the actual sample taken in the lab, checked with the device. The others, all of them are predictions. The blue one is just a little bit, as you see that, it's messy, it looks like, because it takes all that predictions, but rolling 5 minutes average is the purple red one. You could see that it's really matched accurately. It helps us so much to control the process, to stabilize our quality and decrease our energy consumption, because each deviation means in loss on quality and energy. In our APC concept, we try to, at the same time, establish with the partnership with AVEVA about the APC part. Also, we try to check it with our APC system. It's an own-generated since last 1.5 years. We are just connected to the PI directly. We are getting data, and with the help of that MPC concept, model predictive cascade PID fuzzy in it with their combinations. We send the set point to the process to control it. By the help of huge amount of flow data from the Pi, we could use that because it's not possible and human being can control it. By the help of that one, we try to stabilize our process. And predictions, as I said, we are predicting cement strength at 49.06. It's the 28 days later prediction and the effects. We are putting all that data to the Pi and collecting all of them as a hub and sending to our AI system, get the predicted value and send back. And we are following the plant's clinker strengths. As you could see that, it's just in here. The purple one is the actual lab. They put in the lab and wait 28 days, crash it physically. That's the results of purple. Green one is the completely analytical AI adapted predictions. And as you could see that, it's some of them, it's upcoming data. It's the purple goes a straight line, means not appeared yet. The green ones is upcoming strengths. And now the quality people see that I produced today, that 128 days, that green one, you can see it's increasing or decreasing. And according to that one, it managed the process to finer grinding, coarser grinding, or to add blends or to receive modifications, they can do better. Otherwise, we had to wait the amount like that. It's just a view of our renewable as an example we have photovoltaic solar plants in Turkey, and now we are doing investments. It's two 1 megawatt powered plants in our cement plants. This year we will decided to invest 50 megawatts additional in Turkey and also 20 megawatts in Portugal. And we are just collecting all the data. It's a pilot start. We just planted a solar panel. It's a measurement panel like that. It controls the solar energy to how much is it. And each panel just controlled also. If any efficiency loss, it can be from dirtiness or some problem in the panel. We can detect by the help of Pi and people can check it, correct it, and we try to increase our efficiency on the productivity on renewable sources. To wrap up with the Pi, there are many stories I know that I try to quickly to explain to you to show our screens on that part. Visualization on spontaneous analyzing capability, online CO2 emissions, calculations and visualization, predicting NOx emissions, it's also critical, and process predictions and quality and its CO2 footprints. And also higher efficiency. The aim is to because not only direct consumption, indirectly, the energy CO2 effect is critical for us. And VHRs and solar panels. Solar panels we will see. And the result, what's the result? These screens are fresh, just 3 months ago. We just prepared that one to establish. And as I said, we could follow now our CO2 emissions. Actually, it's a screenshot in the live version. It changes in each second. You will see it. Now it's a screenshot from a day of, I think, 3 weeks ago. That time it's 822 kilograms CO2 per ton of cement it was emitting. And the reasons, 66.8 comes from process, 32 from combustion parts. And each plant base is in the bottom line. The gray one is just the circle is turning. We just designed the use of Pi Vision's effect to just matching it together, but we liked it, that one. The outer ring means that without alternative fuel, if we didn't use alternative fuel, what could happen? And what's the gain with the mid one? And we could also show the center on the actual CO2 emissions. That helps so much because people now realize much better. In the before, it's very detailed, huge reports. They don't know anything. Now all the, not only white collar, blue collar people also in the SCADA streams can see that we are emitting that amount of CO2, and they started talking about it. We just summarized that data. An additional screen we added. We actually showed that how much alternative fuel, secondary fuel substitution rate on group basis, also in plant basis, we can show it in group screen, and how much CO2 reduced in this year, since the beginning of this year. When that screenshot is taken in, I think in the March or April maybe, at that date it's 50,000 tons of CO2 decreased by the help of alternative fuel replacing energy efficiency. It's a simple screen, can you see it? But pages of numbers and calculations in the AF to get that number. And its equivalency, when we look at it, nearly 2.3 million. It's also just increasing. 2.3 million trees absorption effect. That means that 50,000 CO2 can be emitted with a number of trees in a year, 2.3 million. And that decrease is as an effect of 1 year's job of that amount of trees. And in the left bottom side, we are showing that the trend, how is going on. And the right side, we are getting from, by the help of API part, the cost of CO2. As I said, at that date, it's 68.9 euro per ton. It's the cost. One side, sustainability, the trees numbers, but the other part is the cost. Because we are in this issue in the Portugal, we are in the European Union. You need to follow it, that the cost, another thing. We are also showing that, yes, we are emitting that CO2, decreasing in sustainability, but it has a cost like that to show our people that effect. Yeah, just to say it's in the end, the annual effect, it's just an base case scenario to explain for us. For each 1%, only 1% of heat energy saving, honestly, I can say that we are expecting at least 2.53%. But it's each 1%. I just give to a figure for a yearly production for us. We could use less. We could decrease 17,500 tons of less coal. We can use it. What's that? It's a yearly heating of nearly 10,000 house. Just yearly heating energy consumption. If we could decrease 1% electric energy, again it looks like we could achieve 4%. At the beginning, it looks like 2%. We have a potential. But if you take it 1%, it's around 12,600 megawatts less energy consumption. It's again nearly 4,000 houses electricity consumption in Europe, in just a medium-sized house. If you could decrease 2% increase in TSR, as I said, we reached from 5% to 30% on today, but only 2% means 30,000 tons of less fossil fuel usage for us, and it's equal to 3,500 cars, passenger cars, CO2 emission per year. It equals like that. 1% of clinker with the high quality, if we could add less clinker and use other natural additives, we could save 110,000 tons of clinker per year. And 3% reduction on maintenance costs by the help of that prediction and anomaly detection. It's just roughly, it's 1.5 million euro saving per year for us. The total effect reaches around 9 million euro with the figures. And as I said, it can be multiplied. It's just a figure for us. We are just near to that one, but not achieved that figures because still pilot applications done. It's just an idea to give that on total basis. If you could apply it, we are planning to do it in upcoming 2 and 3 years. And as I said, our aim to get it to double or triple it. And at the end, just all those advantages mean more than financial things. That figures only 1%, 2% on that. That means 140,000 tons of CO2 reduction in a year. That I showed to you. It's just in the first quarter. It's 50,000. It was. It is much better than that one because not 1%, 2%. That was the actual one. Due to assumptions, it's at least 140,000 tons of CO2, and which equals to 6.5 million tons of trees. And just to give an idea to a forest area to make it, 4,500 football fields. We are talking about a forest like that, and its absorption capacity. It just equals to that one. It's also a motivation for us on the sustainable side. Yes, we are emitting it, but we could decrease it, and we could just get that performance. We know still many things could be applicable because when we start to collect that data, we realize that the topics are huge. Always people was saying that it's the data is the fuel. If you have the fuel, you can do anything in that digitalization thing. Also in cement is like that, I could say that. And I believe if you could do in cement and concrete side because it's very robust and conventional and low-tech part, and people minds are just not so easy to manage it in the cement side. But in any industry, if you have good data, you can do many things. That's our final note in it. Thank you for listening. Just if you have any questions, I'm glad to answer.
Thank you, Berkan. Does it work? 1, 2. Thank you very much, Berkan. Very good presentation again. Well, let's start. If anybody has questions, please raise your hand. We have a mic that can run in the audience. Questions, comments? Yeah.
Thank you. A very nice presentation.
Thank you.
Also with a lot of impact that you achieve. I was wondering, you're mainly focusing on a central AI team which provides those kind of analytics to the plants. How big is your team working on this?
Yeah, this is also a story. It's one of the, I think, in Turkey especially, but also in cement industry, in many companies struggling that one. We are just separated a unit from IT, and I just my department is mainly focused on process efficiency and improvements of plants and benchmarking. But when we start to collect that data, we couldn't get enough response from IT part. They have so busy about that ERP issues and other thing, and they need to touch the operation. It was not like that, and I honestly I can say that it's like in all the other businesses in just that's the main problem. Then we decided to transfer some people from IT, just named them that's OT. They are the first OT engineers in cement industry. Still, it's under my department. There's a department, operational technologies department. Then we just acquired two. One is we said that industrial data scientists and industrial data engineer, we named them, 2 people. But the other, we have a team around 23, 24 people for the project. In the plants, we just selected really interested people from electrical and automation department, mechanical department, chemical engineers, environmental engineers. We designed the department. They look like their side job, but they spend time in the weekends and night in the just before their main roles because they liked that idea. And while adding and fine tuning it, it was like that since the now. We added some new people from also Portugal side, but the aim now it just we established, and by the help of that wind in back of us, just now we are ready to go. That now we will we are planning to in a few months later a department, the digital transformation department. It's also one of the I don't know if some big players have that one, but with our scale, it's the first one. We will have a department like that. But since the now, we just manage it like that with the people, the volunteers. But it's around 23, 24 people. Thank you.
Thank you.
So, Berkan, great presentation. I really enjoyed that.
Thank you.
2 questions. So, first of all, what's been the impact on your team, the management of having the data now that you have access to across the business? And then the second part is, what's been the biggest surprise in the data you've found? Has there been anything that you've discovered that you didn't expect, that was unforeseen, but now you have visibility of?
Mm-hmm. The first one, just when we started, it was not easy because it's not a thing that you can put on your hands. Since the now, honestly, it's also one of them. It's just like in Schneider Electric and the other 3 bigs. There are 4, 5 big companies. They are selling drives, SCADA systems, DCS, PLC units, and everything. They are adding that parts into. They have some packets like that. At the beginning, I struggled so much because they pushed it because it has a story. But we know that it's not easy because everyone tried to connect their own units. But universality and just that flexibility of Pi, it's just impressed us, honestly, me and a few people. Then we discussed, it takes 1 year, more than 1 year, then explain, then get into that thing. Then after just 3-4 months, we showed that Pi Vision screens, and they impressed because it's just in second changed. At the beginning, everyone just saying that, okay, it shows something, is it really true? We need to check it. But the most impressive thing, some plant managers didn't believe it. They said that because it's wave feeders, tons of, like we are in some units, 400 tons, 500 tons of material flowing. We are measuring it with some wave feeders and other thing and calculating all of them by the help of huge volumes. They are passing any deviation. They know that because stock chains and other thing, we are following it. They said that it doesn't work because it just deviates so much. But now the culture changed because we showed them, report them. Now we are pushing them to correct it. Previously, it was manual inputs in the end of the month in the ERP. They are correcting it. Now we are canceling it. We are said that Pi data will be directly go to. We just connected it to ERP. without any manual input. Something happened in the ERP, it creates a crisis because on the finance guys say that what's happening, it's electricity, it's not matching. People need to go that units and need to fix it, need to calibrate it, another thing. That helps us so much, and it impressed especially because it was an issue since decades in this industry. We are measuring many sensors on the field. Everyone's saying that it doesn't measure correct. They are doing something according to your idea. Just it can be an current value, pressure value, or other thing. But now it's just all that values starting to get real, just in correct way. That discipline creates, and that thing is impressed so much. The other thing is just like CO2 screens. Just they impressed because they are using it. It's also helped us. Is a internal marketing for us. Just to screen that how many trees and other thing. It's just a figure in here, as I said. But if I could show that the background, it's just calculating each type of fuels, calorific value, CO2 effect, some factors and other thing, and you could get that number. They see it. And they just say that, oh, it works, and I realized that it's helped us so much. Then we could get enough funds for new team members or additions. That artificial intelligence part, now we are focusing it. It impressed so much. They liked it. What we realized about your question, we were missing so much. Just like a kiln operation, as I showed you. In each shift, an operator sits. Yes, we have PID control, some basic PIDs to automatically control, but they follow only 5-6 parameters. But their screen, there are 4 monitors. In each monitor, 150 different signals changing in each second. They are just watching in it each shift in 8 hours. But they open a trend with only 7 or 8 of them. All the others are going away. Just in the SCADA system, it can store in 3 months, 4 months, and overwrite it. We were losing it, and at that time, why we are just watching it, why we are recording and showing it, that's the question. If something happened, failed the kiln, someone can come and start to open trends. Oh, what happened in there? Try to make that correlations. The most interesting part, I liked it much. Now the newbie engineers also they are just getting that data because so quickly it's ready in our AF structure. Just producing their own Pi Vision screens and try to follow it. It's what happened or try to focus on a unit, a simple unit. It's really great because they say that I can follow now. Previously, they cannot do it. Their own page. When I show that unique page they prepared, I liked it so much because it gives an idea for us. I showed you the general ones, published ones, but there are many also individual pages like that. It's really impressive because now they can make analyzing. Previously, it was just post inspection. It was happened. Now it helps us. It's the biggest thing, I think.
Fantastic.
Thank you.
Any other questions? Yes.
Hi. So first, I want to thank you a lot for this lovely presentation.
Thank you.
My question is about sustainability.
Yeah.
Yeah, and I want to ask you actually 2 questions about sustainability. I want to know how is sustainability is affecting your growth and like in the long term and your long-term profit. How does it really help with that? Like, is it costly to implement these sustainable, implementations in your process and all of that? And the second part of the question is, what challenges are you facing to implement these strategies in your processes and all of that? Mm-hmm. Like the challenges and the growth. How is the sustainability affecting both? Thank you very much.
Yeah, thank you. Thank you for the question. Just as I said, it's just anthropogenic, just in human being related CO2 emissions, it's 7-8% related due to only with cement industry. There's a huge load on cement business, but the problem is that our product is always, I'm giving that example, cheaper than water. A bottle of water, it's just 0.5 euros or 1 euros or something like that. A ton of cement is averagely, we can say 90, 100 euros per ton. If you divide it, it's much cheaper than water. the one thing. The other thing, it's that we are just consuming more than 4 billion tons of cement in a year. There is not any material like that. It just is all consumables, all substance in the world just consumed. The first is water, the second is concrete. It's an interesting info. And people always saying that it's concrete, yes, it's gray and it's not environmental product. But on the other side, there is no any other thing you could produce that amount, that volumes with that CO2. It's not a steel, wood. People say that maybe wood homes, just like that. You're spending much CO2 than concrete. And if you look on the mass, because you're just cutting it, another thing, you're consuming CO2. Or aluminium. It's crazy. It's glass. You can make it glass. It doubled with compared to cement, and you could not produce that amount of glass. There are two things we need just struggling that one. It's very cheap product, need to be produced or everything, and it's so flexible to use and produced in everywhere. But the disadvantage, yes, the main issue is that CO2 emission. That comes from the fuel. Fuel side is 35%. 65% comes from, we are using limestone, calcium carbonate. The issue is that to take that calcium oxide, CO2 sent to somewhere. Now we are focusing on carbon capture units. It's one of the biggest CO2 source cement plant to invest on it. But the issue is that, again, we are talking about a product of 90, 100 euros per ton. Capturing it's triple double of that one. You need to increase suddenly triple just the cost of that cement. It's not so easy to make it. Then we focused more on incinerate. It helps us also, it motivates us to focus. Cement plants working like an incinerating units. The all unrecyclable materials burned. Anything with the carbon including can burn in cement kiln. There are only one incinerators or cement kilns because there is no ash. It gets into the cement, no problem, because our temperature is so high, we can consume it. That's our one of the motivation. The problem is that, as you said, the main question, especially in Europe, the benchmark, the emitting limits decreased year by year. It was started in 30, 40 years ago, as we know at ETS system, taxing system. Till to now, people collected that CO2s. Now all the cement producers have some in their package because it was without any cost. Today it comes, as I showed you, near to 90 euros per ton. A few millions of CO2 credits in their package. But the problem is that benchmark level decreased so much. Today no one can produce around that level. They need to spend that in their packets, that one. They must close, or otherwise they close the cement plants. That's the issue. And that's the reason is the critical, because in our plants in Portugal, we try to also do investment. If you want to continue in those days, you need to invest on CO2 reduction units, capturing additional alternative fuel units. We need to invest on that point or close to put that credits and take the money and close the cement plants. That's the biggest. It's so risky for cement industry. That's the reason. Because of that, it's so critical. In each advantage creates a value for us rather than cost or other thing for sustainability of that issue. But there are some disadvantages, like some regulations. Like in Turkey, still no any regulation. In Europe, it's huge taxes applied. Now, in next year, it will come. Normally, it's a border tax will come. Normally now from Turkey, we can send to Europe. In Europe player, it consumes and give tax. But now say that Europe, okay, the others also need to pay tax. Game is changing. I think United States will come in a 5-6 years. Then Turkey has started regulations like that. It's all over the world that taxing issue will become. People need to obey. If you want to gain much more money and if you want to be in the play, you need to do something. It's hugely critical rather than anything. It's just if you want to just produce cement, sustainability is one of the biggest point for us. It's critical point. Thank you.
Very good. Thank you. Any other questions? We have 2 minutes left.
Hi. I was wondering, when you built standardized structures in AF for all your different plants, did you run into any issues in developing those? Did you have to iterate and work those out? Thank you.
Yeah. At the beginning, it was the biggest problem, the idea, how could we do? We can give the plants, they could do it. But then we decided that to make a plant, virtual plant, includes all the units, like VHR, solar panels, grinding units, 5 grinding units, 6 kilns and other thing, and design the structure like that. before getting the agreement with OSIsoft, still the contracting is going on. We just designed just that one. Till to it goes to each pump, motor, drive, drill down. I remember it's 4. It's child elements. It's just drilling in like that. The list was ready. Then we gave the plant people, the teams also, just they are erasing only, not available ones. By the help of that one, it becomes standardized. Still, we are using that structure. If you will acquire or build a new plant, we say that's the baseline, check it. If anything can happen, we could add it, but still we are keeping it because we just created a structure like that. The whole picture, a plant including everything with the potentials. That helped us. We didn't change it to keep the structure same. Yeah.
Very good. Well, thank you very much, Berkan. Again.
Thank you. Thanks for listening. Thank you very much.